Welcome. Today, 137 of 200 Days of Code, another virtual update from Andersen. So if you want to see more code, go back 1 or 2 days, because today we're not going to show too much code on the screen. This is just for you to also view on your journey to become a developer, to make sure that you also code every day so that you get better every day. And this is more for accountability, to show that Leon Andersen, who started coding exactly 147 days ago, is still working on this code, is still improving. He will be live back with us soon. And without further ado, let's hear his update. Leon Andersen, how are you doing?
Hello everyone, I'm doing pretty good. And yeah, today I did some JavaScript puzzles on recursion. I learned that topic today, very interesting. Aleph told me about referential transparency as well in that context. And yeah, classes and objects did some refreshing since I never used them since the bootcamp. There were some little mechanics or some situations in those puzzles that were new to me as well, and yeah, that was fun. Some refreshing on this keyword, and then I learned a bit about getters and setters and custom getters and setters. I have to say I don't fully understand all the use cases for that, and I don't fully understand why we need custom getters and setters. It has to do definitely with the complexity level. If you want more complex getters and setters, you have to do custom ones. But yeah, I like the only use case that I get so far is validation for getters and setters. But I don't know if there's anything else like validations in terms of form validation, where you basically split the functions into a source function where you can get, that's why it's called getter function, where you can get values from, they return values, and also a different function, a setter function that modifies the values, splitting that into two parts. But I don't really understand. It has maybe something to do with, aside from using it to insert form validation conditions. But I don't know, isn't that possible with like doing it in one function at this or at the same time? I don't know. Probably a good topic to dive into once we're back into real-time code calling. Can't wait for that. So many interesting questions and topics to be discussed. And but yeah, was definitely a lot of fun. Feels really good. And that's it for today. Always be contacting code and always be watching the live streams. Until tomorrow.
Yeah, so let's just quickly go into what Leon Andersen mentioned, the referential transparency, right? So referential transparency means that when you have a pure function, and for those that don't know what a pure function is, pure functions are functions that first given the same input, always return the same output, and second, do not have side effects. Right? And this inc function, for example, is such a pure function, because whatever number you put in here, the output will always be the same given the same input, right? So 1 will always return 2, 2 will always return 3, and so on. So if you have something like this, a variable where you called this pure function with an argument, you could always also just replace it with the result. And that is what's called referential transparency, right? It doesn't make a difference if I write this or this. It's the same. And it can be the same throughout the whole program. And in the whole program, whenever I call inc of 1, I could also just do a fuzzy search and replace it with that. And that's called referential transparency. And Leon Andersen learned this in the context of recursion. So what is recursion? recursion is a function that calls itself. Exactly. So let's say you have factorial, right? For those that skip math class, it's the same as 5 times 4 times 3 and 1, right? So this factorial sign here, the exclamation mark after the number, tells you basically math speak for this. Similarly, like 4 factorial would be this, and so on. So you already see the pattern, right? And the factorial function a factorial function can be implemented with recursion. So you can say factorial number, and then say if number equals 1, we return 1, right? Because 1 factorial is 1. And other than that, we return the number times the factorial of the number minus 1, right? Because 5, when we had that added here, 5 factorial is the same as 4 plus, plus 5 times 4 factorial, 4 times 3 factorial, 3 times 2 factorial, and then 2 times 1 factorial, which is just 1. And this is what this function does. And it calls itself. And this principle is called recursion. I hope you learned something today. I hope you keep on improving code. Leon Andersen will be back with us soon, and then there will be some more live coding. Until then, make sure that you also, if you're on your coding journey, just have some contact to code every day. Watch a video, code a little bit, and obviously if you have days where you can invest 2, 3, 4 hours into coding, that will help a lot. And eventually you will get paid to code, and then you get just better, and you have you basically have paid learning. And that's a great state to be in, because coding is such a valuable skill for you that will allow you to get financial freedom, to work from anywhere in the world, work for everyone. It's a great professional. It's a lot of fun. And it's more relevant than ever, because talking to machines will be the new literacy. Like people who couldn't read years ago, that's the same if you don't know how to program. That's how important machines are becoming in our life. Thank you everyone for watching. This has been day 147 of at least 200 days of code with virtually an Andersen today. He will be back live soon. And me, Andersen from TEDx Dev. Check us out on X. Make sure you tune in. We stream every day. Goodbye.